We're going to take a look at a couple more categories of identities and then see how we can apply them in our class. So we can use the sum identities to derive the double angle identities for our trigonometric functions. So consider the sum identity for sine. We have sine of alpha plus beta equals sine of alpha times cosine of beta plus cosine of alpha sine of beta. Well, how can we use that to determine what the double angle identity is for sine? Well, the double angle formula is really, we want something at the end to say sine of 2 theta, so double an angle at the end. So that's our goal. What I'm going to do is let alpha and beta both equal some angle theta. And if that is the case, then what do we get? Well, we get sine of theta plus theta. And then again, we're just replacing all angles with theta. So I get sine of theta, cosine theta, plus cosine theta, sine theta. So what happens there? Well, I actually have two like terms here. Each of them has a sine theta and a cosine theta factor. So I get 2 sine theta cosine theta. And so my double angle for sine, that formula, is sine of 2 theta equals 2 sine of theta cosine theta. So if I know sine theta and cosine theta, I'm able to find what the value is for sine of 2 theta. All right, let's do the same thing for cosine. So consider the sum identity for cosine. And now we're going to use that to find cosine of 2 theta. We'll take the same approach. We're going to let alpha and beta both equal some angle theta. That will give me cosine of theta plus theta, right? And cosine of theta plus theta, we know that this is really just 2 theta. All right, and then what does the right side become? It becomes cosine of theta minus sine of theta sine of theta. Well, cleaning that up, we see that's just cosine squared theta minus sine squared theta. So that is one expression for the double angle identity for cosine. But I know from my Pythagorean identity that cosine squared theta plus sine squared theta equals 1. So if I replaced cosine squared theta with 1 minus squared theta, as I can do that by my Pythagorean identity, then my double angle identity for cosine becomes 1 minus sine squared theta, and then minus sine squared theta was there before. So again, this 1 minus sine squared theta is what cosine squared theta becomes, and then I'm still subtracting this sine squared theta. This cleans up to be 1 minus 2 sine squared theta. Okay, so that's another double angle identity for cosine. And then my last one is if I take cosine of 2 theta, and this time, instead of replacing cosine squared theta, I replace sine squared theta. So cosine squared theta gets to stay put minus, well, what am I subtracting? Well, just using this Pythagorean identity, right, I can see that if I left sine squared theta on its own side, I would get 1 minus cosine squared theta. So subtract 1 minus cosine squared theta. And again, here I am just going back up to this original one that we found and then kind of playing with that. Okay, so what would this become? Well, it looks like I get cosine squared theta minus 1, and then this gives me subtract another cosine squared theta, but it's subtraction, right? Okay, so what do I mean here? Well, this would be minus a minus, so actually plus. So if I'm adding a cosine squared theta to this just gives me 2 cosine squared theta. So I actually have found 3 different expressions for the double angle identity for cosine. I have cosine squared theta minus sine squared theta, 1 minus 2 sine squared theta, and 2 cosine squared theta minus 1. And the one we found for sine was sine of 2 theta equals 2 sine theta cosine theta. All right, let's do the last one for tangent. So same approach. I'm going to do the same thing. Let alpha equal beta equal theta. So then tangent of theta plus theta, now this is really 2 theta, so I'm developing the double angle identity for tangent, is just tangent of theta plus tangent of theta over 1 minus tangent of theta, tangent of theta, which is 2 tangent of theta all over 1 minus tan squared of theta. So what that gives me is that results in the following double angle identities. So you'll see that here's the one that we found for sine. We have these 3 different ones for cosine, but again, they're all equivalent, so they'll all give you the same thing. And then the last one we found for tangent.